So this is a typical exams question. It could come in this way. This question one is about break-even analysis. The question two is about linear programming. It's also an optimization question. Then, but yeah, it's more of limiting factors. That's the question two. Question three is about demand and supply, equilibrium, and those stuffs. And also, I think business finance. Let's see. Question four. Question okay, that's question four. So what's question three then? Question three is about matrices, and question five too is definitely break even. But yeah, it has to do with uh, more of a quadratic function. And question six also has to do with optimization. So today we'll start from optimization to the top, like question six upwards. Okay. I want to teach you guys optimization. Please, is optimization a problem? When you see a question like this, does it scare you?
Yes, me.
They said given P to be 9Q minus 0.2Q squared. Now, please, let's read it. It says that the demand function P is equal to 9Q minus 0.2Q squared, where P is the price per unit. You see, they told you what the P here stands for. Is what? Price per unit. And they are saying that Q is the output per unit. That's the quantity per unit. It says find the output level at which the total revenue is maximized. Now, you know how to find total revenue. Please, what is total revenue?
Mm.
Hello? Total revenue. How do we get our total revenue? And you want to know the total, it becomes your price, that's your selling price, times quantity. Please, isn't it? That's total revenue. Now they've given you the price to be this. This is price, and they said it is equal to this. So therefore, total revenue will be equal to what? The price, which is 9Q, sorry, 9Q minus 0.2Q squared times what? Quantity times quantity. This becomes the price. Please, do you understand? This becomes the total
Mm.
revenue. So then we solve it. So this Q will multiply another Q. And in mathematics, if like terms are multiplying, like because they are like and they are multiplied, we add their exponent. So here we get a 1 plus 1. So it becomes a squared. So here too we get this Q, 9Q times Q will give us 9Q squared. And also minus 0.2 Q squared times Q will give us minus 0.2 Q cube. Please, do you understand to this point? This is the total revenue. Do you all understand to this?
Yes.
Mm.
Okay.
Please, can you send me the question because I don't have this question.
Oh, I've sent this question to you guys before. You all have this question. Or
Paul, the
No,
exponent
I don't
3
think
on
so.
the Q.
you have it. Holy Ghost fire, you have it.
Let me check.
I've sent it to you.
Paul,
Yes, please.
the 9Q square minus 0.2Q exponent 3. Where is the 3 coming from?
Now, I said that when like terms are multiplying, we add their exponent. Here, the Q for 0.2 Q, here is squared, and another Q is multiplying the Q squared. So, since they are like terms, here has an exponent of 1. So, the 2 and the 1 add to give you what? 3. It's like this. Q squared
Okay,
times Q.
I
Yes,
understand
1.
it
So
now.
it becomes Q squared plus 1, which is what? Q cube. Please, you understand?
Yeah.
Okay. So that's how I got the Q cube. Please, any more question? Now, they are asking for the maximum revenue. Maximum revenue is about optimization. Optimization. Okay. So now, I told you that our function is optimized at its first derivative. Okay, the first derivative, when the first derivative is equal to 0, then the function is optimized. Okay, so we have to differentiate this. Now, for maximum revenue or for optimal revenue, the first derivative of the total revenue should be equal to 0. So we have to first differentiate total revenue. So when we are differentiating total revenue with respect to quantity, please, I taught you differentiation. I said that when y is equal to ax to the power n, I say that when we differentiate y with respect to x, the n here will fall to multiply the a. So we get n times a times x. Then the n will be reduced by 1. Please, do you understand? This is the formula. This is how we differentiate. So if we are differentiating, let's say y being equal to 5x to the power 3, then dy dx, that's when we differentiate y, becomes, this 3 will multiply the 5, so we get what? 15x, then the 3 will be reduced by 1, so we finally get 15x squared. Please, do you understand?
Okay.
Okay. So please, do you understand what I just did? So let me take another example. So if I have, let's say, y is equal to 2x to the power, let's say, 4. I'm saying that when we differentiate y, we get dy dx being equal to, this 4 here will come down to multiply the 2. So we get 4 times 2x, 4 minus 1. So 4 times 2 is 8x, 4 minus 1 will give us what? 3. Please, you understand?
Yes.
Okay.
Yes.
Okay. So likewise, we are going to do the same thing here. Now we are differentiating total revenue with respect to quantity. So the exponent of the Q here would multiply the 9, giving us what? 18. Then the Q will be reduced by what? 1. Likewise, this the other one too. the 3 will multiply 0.2, and 3 times 0.2 is what? Hey, 3 minus 1. So therefore we get the y or the derivative of the total revenue with respect to quantity as 18 kil, because 2 minus 1 will be 1, minus 3 times 0.2 is 0.6 kil squared. Please, do you understand?
Yes.
Okay.
Yes.
So if this is what we get, but I said that the revenues are maximized when the total revenue, the derivative of the total revenue is equal to 0. When the first derivative of the function is equal to 0. So for maximum revenue, it means that we equate this to 0. Okay, we equate it to 0 so that we get to know the output level that optimizes our revenues. So from here, we can choose to use this formula. Please, this formula, you should memorize it before you go and sit for quantity. Okay, you all should memorize this formula before you go and sit for quantity. We can choose to use that formula, or we can even try and, in fact, let me see. Yeah, we can factorize out. Please, 18 divided by 0.6 is what? I don't have calculator here, so 0.6 is 3. Good. Okay, so 0. We divide both sides by 0.6. Okay, we divide all the terms by 0.6. This by 0.6. This two by 0.6. So this 0.6 will cancel the 0.6 here. 0.6 will go into 18 three times. Then 0 divided by any number is 0. So we get 3 kil minus kil squared. We get 0 is equal to 3 kil minus kil squared. This is what we get. So from here, we can factorize out kil. So by factorization, kil can come out. You know, here the kils are 2. So if one is coming out, then the other kil will be there. But since the kil is just 1, it will go out, then it will be left with the 3. Please, you understand what I'm saying? We we
No.
we
You said
factorize out
18
the kil.
divided. Hello.
Yeah, I'm listening.
You said 18 divided by 0.6,
6.
and it's 30.
Oh, it's 30 instead. Oh, okay.
Yes.
I did it 18 divided by 6. Sorry, 18 divided by 0.6.
0.6.
Yes, so it's 30, not 3. Okay. Thanks for the correction. Okay, so this side will be 30, 30, 30. Okay. Now, please listen. This is how I took out the kil. You see there is kil here, there is kil here. So I can just bring one kil out. And when I take the kil out from here, which is the 30 kil, it will be left with just the 30. But the other kil is squared. It means that the kils are 2. So if I bring one out, it should be left with 1 also. Like one will still be there. One of the kils will still be there. Please, you understand?
No.
You don't understand?
Yes.
Okay. What I'm saying is, this is what we are getting. Let's say we have 2x plus x squared. Okay. Because there are double x's here, this x here is also seen as x times x. Okay. So if I'm factorizing out the x, if I bring out one x, from this side, I'll just be left with 2 because 2 times x, this x times the 2 will give you what? 2x. But here, because they are double x, if I bring one out, the other one will be there. So that when I multiply this by this, I get back my x squared. Please, do you understand this one?
Yeah.
So the same thing applies to the other one. Okay, the same thing. So this is what we get. So from here, we say that 0 is equal to kill, then 30 minus kill equals to 0. So you equate this one to 0, then you equate this one to 0. So the quantities are this or that. So from here, we have to find kill, not negative kill. So we make kill the subject by bringing it here. So we get 30 is equal to what? Kill. So our quantities are either we produce nothing or we produce 30 quantities of the products. Now, listen, one of these two quantities will give us the maximum revenue. Okay, please listen. One of these two quantities will give us the maximum revenue. It is obvious from this question that the maximum revenue will be given by the 30 quantities. Okay, the reason being that when we put the quantities in the total revenue function, which is 9 kil squared minus 0.2 kil cube. When we put the quantities there, that's when we put these quantities we are getting 0.3 kil cube, 0.2 kil cube. So when we say, let's say when kil is equal to 0, you know that total revenue will be 9 into bracket 0 squared minus 0.2. Q is 0, so let me place it by 0. Oh, this thing. 0 Q. So from here, we get everything to be 0. So you can see that this is reporting a minimum revenue. But when Q is 30, this is 9 squared minus